Today we will be discussing the purpose of fuses and circuit breakers, what they look like, how they work, and how they fulfill their purpose. We will start with fuses and then focus on circuit breakers. Fuses are meant to protect your wires and electronics from overheating or short-circuiting. They do this by breaking the circuit and not allowing power to flow. In the case of fuses, they are meant to break when there is too much current going through the circuit. Metal ends are supposed to conduct the electricity while the glass insulates it. That means that with a current flowing through the circuit, the glass will be safe to touch. The thin wire inside is what provides the most functionality. This wire has a low melting point. If the wire gets too hot, it'll break, and the circuit will be incomplete. These wires are engineered to withstand a specific current. As you can see here, this one is meant to withstand 1.5 amps. This is also fast acting, so it'll break shortly after the circuit exceeds this 1.5 amp threshold. These fuses, on the other hand, have a time delay. They will not break immediately. They will wait a little while until melting. They make these two types so that a circuit can either be protected by large surges or be protected against a steady increase in current. This third type is a heavy-duty version of the other ones. The glass window is where you can see if your circuit is broken. Because of the wire eventually breaking, fuses are a one-time use component. Once a fuse blows, it can never be reused. You must buy another fuse to replace it. When you do, be sure to get one with the same current threshold. If you do not, then you are at risk of ruining the entire circuit. Much like fuses, circuit breakers are there to protect your wires and electronics from short-circuiting and overheating. Circuit breakers, on the other hand, are not meant to break themselves. They just cause the circuit to be incomplete. A circuit breaker is a lot more complex than a fuse, but only because they provide more safety measures. If you remember, fuses came in two types, time delay and fast acting. Circuit breakers can do both. They can also handle a higher load than most fuses. As you can see here, this one handles 15 amps. Here it is again. Here is the picture of the inside of a circuit breaker. The current begins here, travels here through this path. The red coil in the center is called a solenoid. The solenoid reacts to quick spikes in current and serves as a fast-acting fuse. When this happens, the solenoid will send a plunger through to flick the switch and turn it off, therefore breaking the circuit here. The time delay fuse is replicated in the bimetal rod on the upper left of the circuit breaker. Because of the bimetal characteristic of this, when heated, it bends at two different rates on each side of the strip. Once the strip bends enough, it'll turn the switch off by pressing on here and breaking the switch here. There's one issue with breaking the circuit suddenly, and that's arcing of ionized air. The red box at the bottom alleviates this problem. It has a few metal plates that are insulated where any arcing can go to dissipate. Circuit breakers are more expensive, but they can be reused. In the case of a circuit breaker switching, make sure that you reduce the load on the circuit, give the wires time to cool, and flip the circuit breaker back on. Fuses and circuit breakers are there to protect your circuit and should be used at all times when wiring a building.